Well, so this is last and the final video in this series of priority queue. Now, this video talks about what if you have a complex data type, or you say like you have a user-defined data type. If you talk for an example, let's say we have a struct of, let's call it an interval. So interval is a structure, and in this interval you have, let's say, start time and you have end time. So let's say they are integers, start and end. So if you have few intervals given to you and you essentially want to create a priority queue where we can store the intervals, how do we go about this? So first thing that we change is, rather than int, we say this is a priority queue of interval, vector of interval, and now greater or less will not work because they are inbuilt defined functionals. So what we do is we get rid of this and we say this is our compare function. So this function actually we have to implement. Now the way we do that is, what essentially happens is we create a class and we give the class some name, and that name should be exactly similar to this compare function. And let's create the class. Now in this class we say public, and we say we have to actually overload an operator, and what that operator does is it will actually tell the comparison value of two intervals. So we will be writing that comparison function by operating operator overloading. So when we create this function, ideally what we'll do is we'll say int operator, and this is how we write it. And what we do is inside this we have to take two variables of type interval. So we say const interval ampersand a, and we say const interval ampersand b. So we take two variables, and now what this function is going to work like is, if you remember previously we created a min queue by saying this is a kind of greater function. Now this, assume this to be a greater function, so this should, if this acts as greater, we create min heap. And greater means we have to say if a is greater than b or not. So this is what essentially we are saying. So let's assume that these intervals we are sorting in ascending order of start time. So now test case will also change. So we say first interval is 1 to 5, second interval is 0 to 2, third interval is, let's say, 3 to 9, fourth interval is 2 to 4, and fifth interval is, let's say, 7 to 20. Next is 5 to 11. So if you see 1 2 3 4 5 6, and one more we will give is, let's say, 8 to 21. So these are our 7 intervals that we will be taking. And now if you compare two intervals like 1 5 and 0 2, one is the start, 5 is the end. So what essentially we are saying is we want to sort it based on their start time. So if you want to sort based on the start time, we have to tell which one is greater, and ideally we will be creating a min here. So if a is greater, we should be returning kind of true. So ultimately what we will return is, we'll return if a dot start is greater than b dot start. So this means we are saying that we are implementing the greater function, and this is what essentially we need to do. Now one last thing is, let's say public, and we will create an constructor for interval. So which says int st int, and let me make it underscore so that these variables are different, en, and we say start is equal to underscore st and end is equal to underscore en. So this way we are creating an interval. And after the interval is created, we'll add them to priority queue, and this is how things will move. Now one more thing is, like, this will be start and end in place of x. So earlier we were reading x, so in place of this scanf x, we'll do ampersand start ampersand end. So because our input has changed, so our main function also has changed. So we are reading start and ending. Now in place of adding just x, what we will say is, we will say interval of s and e. This is the interval we will be pushing. Now the moment we push this interval, when we take them out, when we say dot top, so this top will give us an interval back. So we say interval ie is equal to this dot top, and we say ie dot start comma ie dot end is this. So say %d space, or let me print it in a different line. So we are getting the interval back, we are popping that interval, and we are going ahead, right? So we will see like how this compare function is helping us sort these intervals. So let's go ahead and compile our code once again. I think there's some mistake. After class also we should put a semicolon. So stop, compile once again, and we see this got compiled. So let's take our input. So one test case, 7 instances, and the moment we run this, what happens is, you see 0 2 comes first because 0 is start time of 0 is the minimum, then 1 comes, then 2, then 3, 5, 7, 8, and this is how it goes. So ultimately with this greater function we have created a min heap of intervals, and this min heap is actually, if you notice, is converting the is sorting basically only on the start time. If you want to sort on the end time, all that we need to change is just the end. So if we go and compile this once again, so now basically this flexibility we have with this compare function, that whatever we want we can do with it. So here if you see 2, 4, 5, 9, 11, 20, 21. So now it is sorted based on the end times rather than start time, because we have modified the function in such a way. And imagine if we want to have it as max heap, so what we need to do is, essentially you have got the idea that we will say if first is less than second, so less function is what we are applying, that will make it a max heap. So we go ahead, and if you go and run this code once again, so it will be reverse sorted based on the end time. So 21, 20, 11, 9, 5, 4, 2. So ultimately what we have covered here is, if you have any custom data type and you want to make a priority queue of that custom data type, then what we have to do is, first we declare the structure of the data type, we give a constructor, and then we write a class, and in that class we override an operator, and where we take two variables, and based on like what exactly we want to do, we can return a value from here. So this is either lesser or greater, and priority queue declaration becomes the data type, vector of the data type, and there's a comparison function which is name of that is same as the name of class, right? So this covers the last aspect. If you have some custom data type and you want to create a priority queue of that, this is the way you do it.